Hi, we are Triton UAS. We are a student-run project team that designs, builds, tests, and flies our own autonomous airplane to compete each year in the AUVSI Student UAS competition against over 70 teams from around the world.
For the competition mission, there are a number of tasks that we must complete. The first task is to hit a series of waypoints in a specific sequence. While we're flying and hitting these waypoints, we want to avoid both stationary and dynamic obstacles. In our case, the dynamic obstacle is actually going to be another team's UAV that's also flying in the sky. While we're flying, we also have to fly over specific search area and classify ground targets.
We also need to drop a ground vehicle and have it land at one location and drive to a different location. To accomplish all these tests, we design and build our own flight platform, which has to carry computers, cameras, and communication equipment.
Because the project is interdisciplinary, we split the team into three sub-teams that have specific focuses. The airframe team designs and builds the flight platform. The embedded team sets up all the electronic devices on the plane. And the software team designs and implements all the software interfaces that we use on the plane.
The embedded subteam is responsible for designing, building, and configuring the electronic systems that we need to make an autonomous airplane fly.
At the team, we split the projects mainly into two categories, those running at the payload and the other ones running at the ground control station. And at the payload, we have projects such as the power distribution board that powers electronic devices such as the onboard computer, the camera gimbal, and the flight controller, which is, in this case, a Pixar Cube, popularly used for autonomous vehicles. And we also work on the signals board, which handles all the communications. And this uses mainly an Arduino as its microcontroller for handling those tasks. And lastly, with the payload, we also have the unmanned ground vehicle, which uses PID libraries that are written in C++. And we also use MATLAB for testing the control systems running on the vehicle. And then at the ground control station, we also have the antenna tracker, which allows us to always have our Wi-Fi antenna at the ground control station pointing towards the plane for better communications. And for this antenna tracker, we're using a Raspberry Pi, and we're using also Python to program the controller running the antenna tracker. We also work on using the planning software while we're running missions for tuning the plane. And in this case, we use Mavlink packages to configure the parameters. And Mavlink packages are very helpful for us to have reliable small bandwidth packages that go to the plane.
So if you enjoy Triton UAS Embedded, you get to work on interesting projects like the aforementioned antenna tracker. You get to learn useful skills such as microcontroller programming, and you get to work hands-on with the internals of our aircraft. Come join us, it'll be fun.
We're also looking for new pilots for future school years because our current pilot, which is me, is graduating this year. You don't need any prior experience, but if you have any experience, that's definitely a plus. You will receive hands-on training from me, and we will provide all the training equipment such as the transmitter and RC trainer planes. You get to fly what you have built, and it's just a great overall experience for any potential aviation geek.
Thank you for listening. You can find us on our website at twas.ucsd.edu or Facebook at facebook.com/TritonUAS or our Medium at medium.com/TritonUAS.